Welcome, ladies and gentlemen. Welcome to the public forum here of the group exhibit, Hydrogen Fuel Cells and Batteries. We have a program all day long about different items, all about hydrogen and fuel cells and batteries. And I'm now very happy to announce to you, we will talk about Nuvera hydrogen and fuel cell products. And I would like to introduce to you the Director of EU Operations from Nuvera Fuel Cells. It's Mr. Giampaolo Sibilia. Please come up the stage.
Thank you.
Mr. Sibilia, it's a pleasure having you here. Please have a seat.
Thank you.
So this is an open interview, so whenever you have a question, just give me a sign. I'll be with the microphone right with you, and you can ask your questions right away to Mr. Sibilia. First of all, I would like to say welcome back to the group exhibit, Hydrogen and Fuel Cells and Batteries now.
Thank you.
It's been quite a long time, 9 years that you haven't been here.
Yes.
Yeah,
absolutely.
we've been missing you, I can
Yes,
tell you.
we too.
Good that you're back here. Same thing as you've been here already 10 years before, so you have a long history about fuel cells and hydrogen. Can you tell us a little bit about the history of Nuvera?
Nuvera has been formed by two companies, one active in hydrogen generation and one active in fuel cells. So our history has been always in the development of those two technologies, developing fuel cell stack, metallic fuel cell stacks, and developing fuel processor for generating hydrogen. We did in the past, we're continuing, we are doing right now. So basically we have two pillars, hydrogen generator to methane stem reformer, and fuel cell stack for automotive portable application, mobility application. Also aerospace and marine application is something that we are pursuing right now.
You're situated in Massachusetts, United States, but also in Europe, in Italy. Your name sounds very Italian.
Correct. The company has been started in two sites, and we are still in those two sites, in Massachusetts near Boston and near Milan in Italy.
Very good. Okay, so in April last year, Nuvera announced its partnership with Toyota to generate awareness about fuel cell electric vehicles in Massachusetts and across New England. What exactly are you doing there?
Well, basically, we are operating two cars, two Toyota Highlanders fuel cell cars in our headquarters in Billerica. As you said, the intent is to raise awareness of the hydrogen fuel cell vehicles, to experience the 700 bars refilling station with our product. So and then to keep on going on that things. The cars are regularly driven by a Nuvera employee and are used for demonstration and are available there.
This refueling station, they are not electrolyzers, they're steam reformers, aren't they?
They are methane stem reformer. The history of Nuvera has been always to generate hydrogen from hydrocarbon. We did also hydrogen from gasoline, from diesel, and now from natural gas through steam reformer. We're not doing electrolyzer.
Okay, you call it Nuvera's Power Tap. Why did you decide to steam reform the hydrogen? You think it's cheaper, or what is the reason for that?
The reason is to be able to produce, as you said, cheap hydrogen. Our cost is in the range of $10 to $12 a kilogram of hydrogen to be able to power fuel cells. And the steam reformer is because more efficiency can be done as an appliance, can be installed in a filling station to have on-site generation.
Before, until now, you're doing your the power tap with 350 bar, but the Toyotas, they need 700 bar, as far as I know. So you have to go a step further, don't you?
Yes, we are developing this 700 bar refilling for the Toyota cars. We are also developing our own electrochemical compressor to do that. So it's underway.
That's an interesting part, the electrochemical compressor. How does that work?
It's basically a fuel cell working on the other side. Instead of generating electricity, you use electricity to compress hydrogen. So there are no moving parts. The hydrogen resulting is very clean, and is based on our key competence. And the footprint is much smaller than a typical mechanical compressor. And also the efficiency is very good.
So I can imagine there's an electrolyte. No. There's a steam reformer. Yes, as you
Steam
said.
reformer.
And then behind it, it's a fuel cell who gives the energy to compress the hydrogen comes out from the steam reformer. Or do you put the hydrogen through
this electrochemical compressor is, if you imagine an on-site generation in a hydrogen filling station for cars, you will have natural gas in water, you generate and electricity. You compress the hydrogen and you store in tanks, ready to be used to refill cars. So, of course, you can use a fuel cell to power that, but it's not intended right now.
Okay, but it's intended to refuel the Toyotas. You will have 2 Toyotas cars in Massachusetts, is that right?
Yes.
And will drive around with them?
Yes.
Okay. Just for demonstration reasons?
No. This development is also to do a product because in the U.S. there is a traction due to the ZEV mandate in California to do zero emission vehicles. So we plan to do a product, an appliance to do a hydrogen refilling station to be used for cars and also to be used for fleet or of hydrogen vehicles.
It's not everybody in Europe knows. There's a very strict law coming up in California right now for zero emission vehicles, and many companies have to cope with that to have these vehicles. Otherwise, they can't produce anymore.
Otherwise, they have to pay.
Can't sell them, or they have to pay. Yes. So that's a big problem especially for car companies from Far East.
Car companies need to introduce zero emission vehicles or to pay credit. So, and this is an opportunity, of course, for let's say fuel cell companies and we're able to and for hydrogen producers.
Okay, Mr. Sibilia, you have this partnership now with Toyota. Well, is that maybe also a beginning of a very nice partnership to sell them fuel cells?
I cannot detail this, but of course everything can happen, and we hope to move forward with that.
You have experience with that. We have to say, in Fiat, you had a lot of fuel cells implanted already. Fiat Panda Hydrogen. We work
with many OEM in automotive. Fiat is one because of course is in Italy. We started in Italy. We have also worked with others OEM providing stacks and doing let's say prototypes car. We provide stacks also to a small manufacturer of minibus that did the 2 buses that now are in public service in Trentino region. So we had good experience in automotive.
How much of these pandas how many of these pandas are running, still running, or
there have been four pandas.
4 pandas are still running. All in Italy, or where are they?
All in Italy, yeah.
Okay, in Torino probably.
Torino or around the region.
Okay, so there your fuel cells in there. You're very experienced in these fuel cells. Your fuel cells are PEM fuel cells, aren't they?
All PEM fuel cells. All PEM low temperature fuel cells.
The problem with fuel cell cars is always the infrastructure. There is no infrastructure yet in Italy, not even in Germany, but we have 12 refueling stations right now. You do steam reforming. Could you also do onboard reforming? Could be
we did in the past onboard reforming from gasoline with autothermal reformer technology. Then we decided to concentrate our effort on-site generation of hydrogen because we see all the car companies were, let's say, moving in this direction to store hydrogen on board rather than generate hydrogen on board.
You have always the opportunity to raise your hand and give the question directly to Mr. Sibilia if you want to. If that's the case, just show me your hand so I'll be with the microphone right with you. Mr. Sibilia, these power tap units we were already talking about, the steam reforming units for the hydrogen, are already deployed in industrial settings, especially for forklift trucks. Why is forklift trucks such a good applications for fuel cells?
Forklift trucks, if you have fleets of forklift trucks running multiple shifts, and you have a certain amount of numbers of forklift trucks. You have a loss of productivity with the regular battery because you have to replace the battery. The average takes 20 minutes to replace the batteries. It means that in those 20 minutes you are not doing what you are supposed to do with your forklift truck, but you are changing the batteries. So running on a fuel cell, you move from recharging the battery or swapping the battery to refilling the batteries. So you take 2 to 3 minutes. So all those 17 minutes are good minutes to work and to produce. So this is why forklift trucks are attractive for fuel cell if you have, if you have one truck running 5 hours, but if you have a fleet of and multiple shifts of operation.
And forklift trucks always work in big halls, and it's very good to have them with fuel cells so they don't produce any carbon dioxide on site. It's much better, much cleaner also.
Absolutely.
And they run normally 24 hours. So you need one forklift truck less when you use it with fuel cells and, with hydrogen.
Yes, 10% of productivity is the standard. So instead of 10 trucks, you need 9, and you operate with 9, you have the same throughput.
You have other applications for your fuel cells, like say in reefers that are transport refrigeration units.
Yes.
You have to know, well, there is they need to cross the country in the United States, and they have refrigerated goods in the back, and they have to keep it cool. So they need APUs, auxiliary power units.
Yes, we are now developing a reefer unit, which is a good application because the lorries that take the frozen, let's say, cold food around starts from logistics centers where hopefully there is a forklift truck run by others, so there is hydrogen availability, so there is not the problem of refilling that reefer units. So you can, instead of using a reefer with a diesel engine, you use one with fuel cell, and you can run more quietly. You can park maybe the lorry somewhere where you need to discharge and operate it quietly without disturbing the surroundings. So this is a good advantage because some municipality doesn't allow maybe to run in certain hours.
So if these truck drivers across the country, they do have to make pauses, of course, and when they pause, they normally leave their engine running, idle running, but that's not allowed anymore in the United States.
In some places, yes, it's not allowed. But this you need an APU. We are doing the reefer, but it's the same concept. Fuel cell APU, you can keep on running without using the main engine.
Right, with the APU, auxiliary power unit, can keep them running. And how do you do it there? Also with the hydrogen, or do you do onboard reforming?
We are not doing APU right now for trucks, but it can be done by the hydrogen or onboard reforming. There are many applications.
Right. And the advantage would be these reefers are also at the same places where the forklift trucks are working.
Exactly. Yeah. So you can refill both the forklift truck and the reefer with the same filling station.
Okay. So where they are already installed, they can be used doubled. Another application would be aerospace application. Also there they need APUs.
Yes. Aerospace, but there is the boat over there. Basically, the idea is to replace the APU on airplanes with a fuel cell unit to make energy, electrical energy that can be used to refrigerate the airplane, but also to start up the engine. But in addition, there are other byproducts of the fuel cell can be used in this application. One is the water produced by the fuel cell, so the airplanes can take off with less water, saving weight and saving fuel. And also the depleted air coming out from the fuel cell can be used on board on the plane to purge the fuel tanks. Today the airplanes take off with the tanks of nitrogen to purge tanks, and this can be eliminated by using the depleted air coming from the fuel cell. So there is a multiple usage of output of a fuel cell in aerospace application. And
you have to know that hydrogen is very light, so weight is always a problem with flying. Yeah. So it's a light fuel you can take off with, and you use both what comes out. So it's hydrogen, it comes out O, which is oxygen, and water you use on toilets, actually.
Yes, exactly.
Well, there will be a time when we will have a shower on board of a plane, will we?
A shower with the hydrogen, water generated by the fuel cell, sure. Maybe.
I would love to see that, you know. So this is only for APUs, the auxiliary power units. You need electricity on board of a train, either during taxi on ground, but also in the air.
Yeah, whenever you use the APU, yes.
Could you imagine one day we fly with fuel cells? Could that be possible?
Technically possible. Has to see if it's economically viable. So far, the discussion are all for APU, not for the main propulsion. But, maybe in the future.
Well, actually, there was a plane flying with hydrogen, but they burned the hydrogen. It was a Tupolev already in the 70s. The Russian did it already. They switched off to hydrogen, so it worked once, but they burned it. Maybe not the best way to use it. Very well, very good. Are there any more questions from your side you can give to Mr. Sibilia directly? If that's not the case, I would like to invite you all to visit the booth of Nuvera, which is D72, just down the aisle here on your right-hand side, and you can find him there halfway to the technical forum. He will answer all of your questions over there. I would like to thank you very much for your attention, and thank you very much, Mr. Sibilia, for this interview.
Thank you. Thank you.
It was a pleasure.
Thank you.